Hey guys, it's Miss Damaso. Today we are going to do our week 3 video. It's the only video that we have this week. It is our study guide for chapter 7 because we are now finished with all of our trigonometry as well as the unit circle. So today we're going to do a study guide for this chapter. You can complete the study guide either on your own or you can do it with me in this video, kind of whatever works best for you. You can also expect to see problems that look very similar to these that are going to be on your assessment later this week. So my suggestion is to make sure that you know how to do every single problem as we're going through here. And then of course you're going to have an opportunity to meet up with me if you would like on Microsoft Teams to ask some additional questions. So let's get ourselves started. We're going to start with finding some values of the 6 trig functions for the angle theta. We're going to give our answer in simplest radical form. So remember, since we are talking about trigonometry, we're doing that sine, cosine, tangent, as well as the reciprocals, the secant, cosecant, and cotangent. So I always like to make sure that I have my trig functions right now, my SOHCAHTOA, just because I feel like it makes it way easier for me. Okay. So in my first triangle here, I've got a right triangle. I am given my reference angle thetas right over here. I need to do all 6 trig functions for this angle. In order to do that, I have to have all 3 of my sides given to me or found out. And right now I only have 2 of my sides, so I'm going to figure out my third side. I know that I can find an unknown side length of a right triangle if I use the Pythagorean theorem. So I'm going to do that for this problem. So it's a squared plus b squared equals c squared. The a and the b are your legs. The c is your hypotenuse, which is across from the 90. So I know my c value is going to be a 24. I'm going to leave my a value as the blank one. And I'm going to plug in 21 for my b value. Okay. Then what we're going to do is we're going to go through, we're going to square those numbers. So 21 squared gives me 441. And 24 squared gives me 576. Then I'm trying to get the a by itself, so I'm going to take this 441, I'm going to subtract it from both sides. And when I do that, I get a squared equals 135. And then to get a by itself, I'm going to square root both sides. So if I square root 135, I do not get, it is not a perfect square, but I can break it down to be a perfect square times another number. So I can divide this to be 9 times 15 gets me to 135. The square root of 9 is 3. That's a perfect square. So my a value is 3 radical 15. So this last side over here is 3 radical 15. Now, I know that this theta is where I'm looking. That's my reference angle, so I'm going to mark my sides as necessary. So across from the 90 we know is the hypotenuse. Across from the theta is my opposite, and next to my theta is my adjacent. Now that I have all 3 sides, I can do all 6 trig functions. So the sine of theta is going to be opposite over hypotenuse. So that would be 3 radical 15 over 24. And I can divide both of these numbers by 3. So I can reduce this to be radical 15 over 8. And there's my sine. Cosine is adjacent over hypotenuse, so that would be 21 over 24. I can reduce that, right? Divide them both by 3. I get 7 over 8. Last one is tangent, which is opposite over adjacent. So 3 radical 15 over 21. Can divide them both by 3, so I get radical 15 over 7. So I've got my sine, cosine, tangent. Now I need to do their reciprocal values. So reciprocal of sine is the cosecant. And I'm going to go back to the original one, and this is the one that I'm going to flip. So it's going to be 24 over 3 radical 15. I already know I can reduce this, right, to be, that's a 1, and this becomes an 8. And then I'm not allowed to have a radical at the bottom, so I move it up and I clean it up. So this becomes 8 radical 15 over 15. And I can't reduce the 8 and the 15, so that's my cosecant. Secant, I'm going to take the reciprocal of the cosine, so instead of 7 over 8, it's going to be 8 over 7. And then my last one is cotangent. Okay, so I'll actually come over here to this latter one so I can skip the step of reducing. So it's 7 over radical 15. But remember, I can't have a radical at the bottom, so I move it up and I clean it up. So it's 7 radical 15 over 15, and I can't reduce that anymore. So there are my 6 trig functions. Okay. Number 2. If the cotangent of theta is radical 3 over 5, find the remaining 5 trig functions. Now, I would always suggest to draw a picture just because it makes life way easier if you can visualize it and see it. Otherwise, it's super, super hard to do. Okay, so I'm going to put theta somewhere. It doesn't really matter where you put the theta. I'm going to put it at the bottom here, but you really can put it wherever you want. So I know cotangent is the reciprocal of tangent. So that means if I've got radical 3 over 5, that means cotangent is really the adjacent side over the opposite side. Adjacent and opposite. So in my picture here, whichever one is the adjacent to the theta, so it would be the one that's right next to it, I'm going to put a radical 3 here. And then opposite of the theta, I'm going to put a 5 there. And I don't know what my third side is, so I'm just like the last problem, I'm going to have to do the Pythagorean theorem for it. Okay, A and B are the legs, which is what I'm given. I'm actually trying to find the hypotenuse this time. So I've got 5 squared plus radical 3 squared equals c squared. Okay, 5 squared is obviously 25. Radical 3 squared just means the radical and the square cancel each other out, so I'm just left with the 3. And then I can add them both together. So I end up getting 28 equals c squared, and then I square root. Now, 28 is not a perfect square, but I can break it down to be a perfect square times another number. So I can break this down to be radical 4 times radical 7. And I know that 4 is a perfect square, so it's really 2 radical 7 is my c value. So over here I'm going to put 2 radical 7. And then I'm going to make sure that I mark my sides. So I know that the radical 3 is the adjacent. I know that the 5 is the opposite. And now I figured out what the hypotenuse is. It's 2 radical 7. So with those 3 now, I can write the sine, cosine, tangent, cosecant, secant, and cotangent, just like I did for the last problem. Okay, so sine is going to be opposite over hypotenuse, so 5 over 2 radical 7. I know I can't have a radical at the bottom, so I move it up, clean it up. So it becomes 5 radical 7 over, and then this would just become a regular old 7, so it's 2 times 7, which gives me 14. And then I can't reduce it any further. Okay. Cosine is going to be adjacent over hypotenuse, so radical 3 over 2 radical 7. Okay, can't have a radical at the bottom, so I move it up, clean it up. But when they're both radicals on the inside, I'm going to have a radical 3 and a radical 7 on the top. I can multiply 2 numbers on the inside of radicals together, so I'm going to get 21. And then at the bottom, I've got 2 times radical 7, which is, 2 times just a regular 7 because I've cleaned it up, so it's just a 14 at the bottom. Okay, last one is tangent. Tangent is opposite over adjacent, so it's 5 over radical 3, and then I move it up, clean it up. So it's 5 radical 3 over 3. There's my sine, cosine, tangent. Now I'm going to do the reciprocal values. Okay, reciprocal of sine is the cosecant, so I'm just going to flip. And go back to the original. So it's 2 radical 7 over 5. I can't reduce that in any way, so I leave it alone. Secant, again, I'm going to go back to the original. So I've got 2 radical 7 over radical 3. And then I move it up, clean it up. So it becomes 2, and then 7 times 3 is a radical 21 over, the 3 becomes cleaned up, so it's just a plain 3. And I don't even really need to do the cotangent. Why don't I need to do it? Is because it's already given to me. It's radical 3 over 5, which I can see it is over here anyway. Okay, there we go. And I've got my 6 trig functions for that one problem. All right. For numbers 3 and 4, we're going to find the missing side lengths, and then we're going to round all of our answers to the nearest tenth. So I am given the reference angles right over here. It's 25 degrees. I would always suggest marking it or coloring it or something. Then I'm going to label my sides. So opposite of my reference angle is the x. And then the 34 would be considered adjacent. And then I say to myself, okay, which one uses adjacent and opposite? Well, that would be tangent. Uses the adjacent and opposite. So I'm going to say the tangent of 25 degrees equals opposite over adjacent. So x over 34. Now, I want to get the 34 by, the x by itself. So I'm going to get rid of the 34. I'm going to multiply both sides by 34. When I do that, on the right, it's going to cancel. I'm left with 34 times the tangent of 25. And all I have to do now is put that in my calculator. Now remember, if you're putting it in your phone, I unfortunately can't show you because I'm using my phone to tape myself right now. If you're going to put it in your phone, you have to make sure you put the 25 before the tangent. If you're using a calculator like this, you can just straight up put it into your calculator. So you can do 34 times the tangent of 25. Make sure you're in degrees because we're talking about degrees right now, not radians. So please make sure that either your phone or your calculator has a little degree mark. We're going to round our answers to the nearest tenth. So my x is approximately equal to 15.9. Easy enough. Okay, we're going to do the same thing for our number 4. All right, so here's my reference angle. It's 48 degrees. It's given to me. And now I'm going to label the sides. So I've got across from the 90 is the hypotenuse. And right next to that 48 is going to be my adjacent. And then I say, okay, which one uses the hypotenuse and the adjacent? That would be the cosine. So I'm going to set up my equation to be cosine of my reference angle, 48, equals adjacent over hypotenuse. So 17 over x. Now I'm going to get the x by itself. So I'm going to multiply both sides by x. I get x times the cosine of 48 equals 17. And I still don't have the x by itself. This is x times the cosine. So to get rid of it, I'm going to divide both sides by the cosine of 48 degrees. Okay, so this is just a problem for my calculator. 7 divided by cosine of 48 degrees. And I get x equals, 17, I said 7, my bad. X equals about approximately, we're running to nearest tenth, so it would be 25.4. And I'm finished. Easy peasy. Now, for 5 and 6, we're going to find the value of theta. As soon as it asks you to find the value of an angle, that means instead of using regular sine, cosine, tangent, we're going to now use the inverse. We're going to use ones with the little negative ones next to it. So here's my reference angle over here. Now I'm going to mark my sides. Across from the 90 is hypotenuse. Across from the theta is the opposite. So I say which one uses the opposite and the hypotenuse? That would be the sine. So I've got sine of theta equals opposite over hypotenuse, 17 over 18. Now, if you're using a phone, first thing you're going to do is you're just going to do 17 divided by 18. You're going to get a decimal. So you should get about 0.94 with the 4 repeating. And then you're going to take that number and you're going to push second sign or shift sign depending on what you're using. If you're using just a regular old calculator, you can actually put this whole thing in your calculator by pushing second sign and then putting the fraction inside of it or the ratio inside of it. And you will get that your theta is approximately equal to 70.8 degrees. And remember, it's an angle, so we're in degrees. All right, next one, number 6, same sort of setup. Here's my reference angle theta. I'm gonna mark my sides. So 31 is opposite and 42 is the adjacent. So the one that uses opposite and adjacent would be the tangent. So the tangent of theta equals opposite over adjacent, 31 over 42. And again, you can just put this straight into your calculator. If you do 31 divided by 42, you're gonna get a decimal. You get about 0.7381, and then push that to the inverse tangent. You will get approximately 36